You just bought your first CNC machine and you're still calling these drill bits and you think this one's just a worn out drill bit, you need to watch this video. These are carbide end mills and this is the bread and butter of CNC tooling. To start out, the one on the right is a ball nose end mill. Notice it is rounded. The end mill on the left is a flat end mill with no corner radius. Not a drill bit. So I'm going to assume you have no idea about the difference in an end mill and a drill. But most people are familiar with the drills, so let's compare. So all cutting tools have three components: a shank, flutes, and a cutting tip. The cutting tip is designed to remove material. The flutes are designed to evacuate the material that's cut, and the shank is designed to hold the tool in a spindle or something that rotates to make the tool cut. The geometry in a drill and an end mill are significantly different. The drill is made to be plunged into a surface. The end mill is made to be moved along a surface and remove material while it's moving. If you move a drill in a cut, it will break every single time. It's not designed to cut on the side flutes. It's only designed to plunge straight into the material. And also with that, if you'll notice how much material is removed with the flutes on a drill, the end mill is much more solid by design because it's made to cut on the sides and with partial engagement and even full engagement on the cutting tip while it's moving. This is how you make slots, profiles, things like that, where a drill just makes a straight hole. This is the main difference in drilling and milling. And you bought a milling machine, so we're only going to focus on milling tools. So let's take this block of aluminum and explain different tool types that make different features. So, as we all know, if you want to drill a straight hole, use a drill. If you wanted to profile the side of this part into a specific profile, or make a slot, rough down the top, whatever, you would use an end mill. If you have sharp corners, or you want to countersink, chamfer, anything like that, you would use a chamfer mill, countersink tool, depending on the application. And then you would want to make threads. So you'd use a tap, right? No. This is focused on the small hobby machines that are not going to have enough torque to rigid tap. If you don't know what rigid tapping is, we can go over that later, but tapping takes a lot of torque. You could do this by hand, or you could buy a thread mill. You have a CNC machine, so you should just use thread mills, and we're going to go over that. Also, if you wanted to only remove lots of material on the top surface or make this surface mirror smooth, you would use a Facemill. We're going to go over that also. Those are pretty much the basic types of tools you would need for your brand new CNC machine. So if you wanted to make something that's not flat, you would use a ball nose end mill for finishing. You can rough the non-flat surface with a flat end mill, but the ball nose end mill will give you that super smooth finish on angles, radius, things that aren't flat. So you also need a ball nose end mill and probably a radius cutting end mill if you want to put fillets or anything round on the top edges of your parts. Before we get into what tools to buy, let's talk flute count because you're going to run into this. This is a 4-flute end mill. Notice the 4 cutting flutes. So how do you determine the flute count? It really depends on the material. For these machines, granted they say they can cut steel and titanium and all this ridiculous stuff, you're most likely going to cut aluminum, plastics, things like that. For cutting steel, stainless steel, things like that, I'm not even going to touch titanium. If you're cutting ferrous metals or metals that have a high hardness and don't make large chips, large stringy chips like aluminum, you're going to want a 4-flute end mill. The 4-flute end mill is more rigid, think of the drill, because there's less material removed by the flutes. So this is a more rigid tool. So why would you not use a 4-flute end mill on everything since it's rigidity and we're on a small machine and we're fighting rigidity all day? So the problem is the small flutes don't have enough room to evacuate large stringy plastic chips, wood chips, aluminum chips, things that these machines are most likely going to cut. This is why you rarely see a 4-flute end mill used on these small machines. It all depends on what you're doing, but I would stick, first off, I would buy a 4-flute end mill in a couple sizes because you may get the random steel job or something like that. But most of the time, you're going to use 3, 2, and 1 flute end mills of ball nose, flat nose, radius nose, all things like that. Stick to 3 and lower on flutes because in reality, aluminum's probably going to be the most metal material you're going to cut on these machines. So now that we went over flute geometry, let's actually go shop. And this is the part that's going to hurt your wallet. So, before we get to anything else, I'm not a machinist, don't claim to be. This is a beginner video, so if you are a seasoned machinist, likely you already know everything about this video. The purpose is for beginners, so if I oversimplify a lot of information, I'm just trying not to get too far in the weeds. So anyway, before we talk about tools, let's talk about how we're going to hold the tools in the spindle. So this video is focused on the Makera machines and the Nestworks C500. We already know all of the Makera machines and the Nestworks C500 have a DGZ 60E spindle collet. If you do not have these machines, you likely have an ER11 or ER16 collet. I've talked about this difference in some other videos, but we'll go over it again. If you have an ER collet, you match the collet size to the spindle and you load the tool in the collet in the spindle. If you have a DGZ collet, the collet threads in a spindle, if you are a machinist, more like a 3C or 5C collet, and the tool comes out of the spindle, but the collet stays. So this means you don't need as many collets, but your tool shank diameter has to be specific to the collet that's in the spindle if you're going to use an automatic tool changer. If you're going to do manual tool changes, the shank either has to stay the same or you have to unthread the collet out of the spindle. If that doesn't make any sense, go watch some videos, but this is the DGZ compared to an ER collet. So with that being said, they make a lot of ER collets. You may or may not be lucky, whatever, that's up to you. The DGZ collet means you don't need a lot of collets, and they don't make a lot of collets. Now you can get these a lot cheaper. I just pulled this up because all the sizes are in the same ad. You can get these for like 25 bucks. You may have to test some stuff out. Some of them may not be real concentric, real accurate. Anyway, they make a 3mm, 3.175, which is 1/8 inch, 4mm, 5mm, 6mm, 6.35mm, which is 1/4 inch, and 8mm. So this means if you have a DGZ 60E collet, you can only buy tools with shanks of 3, 1/8 inch, 4mm, 5mm, 6mm, 1/4 inch, and 8mm. Do not buy any other tools with a shank other than these diameters. If you have this collet, they will not go in the spindle. So buy a couple of these. I would buy 2 of every size personally. That way you can run literally any tool on the market and have a backup in case you kill one on accident. Because crashes are going to happen. You're a beginner. Also, we're going to go shopping on Amazon. Now I know you're going to say, Amazon tools are junk. You should treat these beginner tools as a disposable list of tools. You're going to break tools. You're going to wear tools out. This is to get you started on the lowest budget possible. If you go out and buy a $60 1/8 inch end mill and break it the first time it touches the part, you're going to be pretty sick. And the reality is, you're going to break it anyway. So you might as well buy cheap tools. Some of these may be good quality. We're just going to go over, for one, what comes with the machine, the Nestworks C500 specifically, and also my recommendations and what I'm going to buy in addition to what comes with the machine so I can break tools just like you. So this is straight out of the latest Kickstarter update. There are 2 tooling packages depending on what you specified, metric or imperial. I specified imperial. I live in the US. It's probably going to be easier to get imperial tools, but we're buying China tools anyway. Doesn't really matter. They're pretty much going to be the same. You can see the metric right here. I'm going to specifically discuss the imperial because I am in the US. If you go buy quality tools in the US, you're likely going to get a better price on imperial shank tools because 1/8 inch, 1/4 inch, things like that are a lot more common. So I'm going to discuss the imperial. So this is what comes with the machine. So we've got an 1/8 inch diameter, 2 flute, DLC coated end mill with the 1/4 inch collet and the 1/4 inch to 1/8 inch adapter. We're not going to discuss adapters here. We'll talk about that later. Also, a 1/4 inch diameter, 3 flute, DLC coated, 2 inch end mill with the 1/4 inch RFID tag. We'll go over that in another video too if you want. We also have an engraving bit. I'm on the fence about this. You can engrave with a chamfer mill, do whatever you want. I may use this, I may not. It's also going to come with an M4 by 0.7 thread pitch thread mill in 1/4 inch shank. Also a 2 flute 1/8 inch ball nose end mill, 2 inch DLC coated, and a 1/8 inch 90-degree chamfer mill. The chamfer mill is definitely a must over the engraving bit to me. All this comes with the machine. But anyway, and then we're also going to get the RFID collars for the tool changer. That's what these are. And the reducers, if you have a 1/4 inch to 1/8 inch reducer, things like that. Because remember, if you have a 1/4 inch collet in the spindle and you want to run an 1/8 inch tool, you either have to pull the collet out or load a reducer onto the other tool in the tool changer. And then you're also going to get an 1/8 inch spindle collet and a 1/4 inch spindle collet. So this is what comes with the machine. Now we're going to go over what I would add on top of that. So this video is already getting a little long. We're going to go through this real quick. I'm going to recommend an 1/8 inch, 2 flute, flat, square, whatever you want to call it. Or you could get corner radius. Either is fine, whatever you can find cheap, doesn't really matter. I'm going to recommend an 1/8 inch 2 flute. I'm also going to recommend an 1/8 inch 3 flute as a finisher, or you could get into some steel, maybe some soft steel with a 3 flute. Like I said, we're going to focus on aluminum, copper, plastic, things like that. So 1/8 inch 2 flute, 1/8 inch 3 flute, and I know this says extra long. This is a huge mistake. Get the shortest tool you can possibly get for the work you're doing, because you're always going to fight rigidity on these small machines. Also, you need to step up and get a bigger end mill. 1/4 inch for this one. At this point, the Nestworks C500 has enough horsepower to push a 3 flute 1/4 inch. I'm going to go with that. If you have one of the lower power Makera machines, you may want to get a 1/4 inch 2 flute. The C500 can push it. I'm going to remove the most material possible within reason, so I'm going with the 3 flute for my aluminum. This could also be a finisher if you're on a lower horsepower machine. So those are your end mills. You may want to throw a ball nose in here also, an 1/8 and 1/4. The machine comes with one. You're not as likely to break a ball nose as you are roughing with a flat end mill. But anyway, those are your end mills. I would personally add another chamfer mill. You're not as likely to break a chamfer mill, so you might want to get a better quality one. The machine comes with an 1/8 inch. I'm going to go ahead and get a 1/4 inch also, because I'm likely going to be using bigger tooling anyway with the 1/4 inch collet in the spindle. So add a chamfer mill, maybe get 2 of these. You're going to want to put chamfers on your parts. This is pretty critical, and this one's going to stay loaded in the tool changer at all times in my opinion. So these are our cutting tools. Let's make some threads. So like I said, if you want to buy taps to clean the threads up later, that's fine. You're not going to put a tap in the spindle. It's not going to have enough torque to turn it. So thread mills will do a variety of thread diameters and thread pitches. Actually, theoretically, if the thread mill fits in the hole, it will do any diameter. But the pitch is determined by the geometry of the cutter on the end of the tool. So certain thread mills can't do certain thread pitches. This set of these diameter thread mills, this is why I picked this one for the video, you can tell I have the diameters down here, and you can also relate that to the pitches that it will do in metric and standard right here. So this pack of thread mills will do almost every thread you could possibly put in a part. If you get some really weird stuff or a really large diameter thread, you would likely need to get up here into this, but you may have to order specific tools. You're going to order specific tools once you start doing actual work anyway. This is going to get you started on thread mills. This one's going to be the most controversial. They don't really make a Facemill for this machine because the machine doesn't have a lot of power. I can't recommend you hogging material like a Facemill in an industrial environment. If you have access to a machine shop with a grinder, you could get a larger diameter Facemill of like a 1-inch Facemill with a 3/8 shank or 1/2-inch shank, grind the shank down where it'll fit in a 1/4 inch or 8mm collet, depending on your tooling setup. You're still not going to be able to hog material, does not matter. Please do not put a 4-inch Facemill in your machine. You're going to knock the spindle out immediately. That's why this one, just for discussion, we're going to go with a 1-inch Facemill. This is bigger than any tool you can put in the spindle. It is only for cleaning up surfaces or flattening out stock. You are not going to rough with this. You're not going to take a 50,000ths depth of cut. Also, with that being said, if I got this tool, I would remove the 2 vertical inserts and only use the other inserts with the rake angle. Those are going to give you the best bet for low horsepower spindles, in my opinion. So look for that. None of these like router wood surfacing bits are good geometry for removing metal at all. This one with the rake angle would clear the chips out a little bit. Just don't flame me for this, and please do not try to hog with this. You're going to blow the spindle out of your machine. This is only for final top and bottom surface cleanup, in my opinion, but I wanted to talk about it. So I'm going to pull up another picture of the collet just for this dimensional diagram. So this dimension's not on here, but I wanted to discuss this. I said earlier, you want to get the stubbiest tools as possible for the machine. So typically like a 1/4 inch tool would be 2-inch length. Well, these collets only have a 28mm depth. That's about 1 inch. So if you get a 1/4 inch tool, you're supposed to be 3 times the diameter max stick out, roughly. That's 3/4 of an inch. So if you get a 2-inch overall tool, you're already sticking out past that. So you've only got basically 1 inch that the tool can go in the spindle, and the rest of it's going to hang out by design. So you don't really want to go with standard length tools if you can get away from it. Try to get the shortest tools as possible. So keep that in mind. This is my last recommendation. Also, if you want to get twist drills, you're going to have to keep these really small because just like taps, drills take a lot. You could peck drill, but the machines are not going to have a lot of torque. I would say stay 1/8 inch diameter and under on drills if you want to start holes like that and then helical mill the holes out to finish diameter. It's probably not going to turn a 1/4 inch drill even though it'll fit in the spindle. So I know I've missed a lot of stuff. I tried to keep this video short. If you guys want to hear more information about any of this tooling, I also may make a video on work holding because the tools don't matter if you can't hold the workpiece. So thank you guys for watching. Please let me know if you want to hear more, and subscribe and throw your ideas out, and I'll make more videos on them. Thank you guys for watching.